Morning, everyone, and welcome to the second day of the Shrug 2021 workshop. My name is Janine Fear, and I will be moderating this session entitled, and I lost it already, Using Spatial Data to Assess Climate Vulnerability and Risk with Ms. Kim Rhodes. Kim is with Fernleaf. She is their GIS and Resilience Analyst. She'll be presenting today, as well as giving a demo of her tool. And so what we'll do is we'll have questions at the end of her presentation, and then she'll start her demo, and then we'll have questions after that. And with that, I'm going to stop sharing my screen, and I'm going to hand it over to you, Kim.
Excellent. Thank you. Somewhere here. There we go. Okay, Janine, can you see my slides? You're muted.
My apologies. I do see your screen, yes.
Okay, cool. I just wanted to make sure it picked the right screen.
I see presenter view, so you might need the other screen because I see your web browser as well.
Okay. So you can see, if I toggle to AccelAdapt here, you can see that?
I still just see your web browser and the presenter view screen.
Weird. Okay, let me stop and see if it gives me the option. Here we go. Okay, now I think you should be seeing the right screen.
Correct.
Okay, awesome. So, hi everyone. Good morning. Thank you all for having me. As Janine said, my presentation for you all is called Using Spatial Data to Assess Climate Vulnerability and Risk. Just really quick, my name is Kim Rhodes. I'm the GIS and Resilience Analyst for Fernleaf. We're a small group that's based out of Asheville, North Carolina, and I'm actually located in Salt Lake City, Utah. So if you're seeing my webcam, it is a little dark here. It's 7 o'clock Mountain Time. Early bird gets the worm, right? So today our agenda is to go through the steps to resilience. I'm going to give a quick overview of that framework that we use. And then I'll talk a little bit about our work with the City of Tallahassee and cover some different vulnerability and risk concepts. And as Janine said, then I'll jump out into AccelAdapt, which is our online tool, and give a little demo of that. And we'll have some time kind of throughout there for some questions, but questions at the end as well. So the assessment framework that we use is the U.S. Climate Resilience Toolkit Steps to Resilience. This is a framework that our team actually developed with NOAA. It's a stepwise framework, and if you're familiar with the toolkit, on the website, the steps to resilience looks a little bit different. It kind of has a linear steps 1 through 5. We're working with NOAA right now actually to kind of redevelop this graphic, and this is sort of what we've come up with so far to kind of nod a little bit to this iterative process. And really the city has demonstrated that, as I'll talk about a little bit later in the presentation. But our assessment uses this framework and really gets to this step 2, this assess vulnerability and risk in the dotted orange box here. So we first take communities through this explore hazard step, looking at assets, and then we take that information and do some spatial assessments for assessing vulnerability and risk. And then we use that information to continue to walk through the rest of the steps to resilience. So as I noted, this is an iterative process. We like to call it a living assessment, and that means that it can be updated. So in 2018, we started working with the City of Tallahassee to go through the steps to resilience, and they came out with the Tallahassee Community Resilience Plan. Some of you may or may not be familiar with that, depending on your location. This report puts out goals and strategies, and then annually assesses these goals and strategies to inform progress and talk about next steps. And so talking again about that iterative process, Tallahassee is the first city that we have done an assessment refresh with. We completed that this past spring in May, I believe, and this is the assessment area for the city that we use. So it's a combined boundary of the city limits and urban service area. And so with that assessment refresh, we were able to pull in newer and updated data sets on both the parcel data and other asset information, as well as threat data. So the threats that we've assessed for the city, we kept them the same as we did in that original assessment. But again, we were able to pull in that updated information. So we assessed all of these spatially, looking at flooding, storm surge, wildfire, and then at extreme heat at what we call a screening level. And we can talk about that a little bit more later, but essentially, because we don't have modeled extreme heat data like we would for flooding, we have to get a little bit creative, and we kind of look at that at a little bit higher of a level at the census block group. And then also, again, within that step one, we're looking at different assets. And so assets are really kind of one of the more important parts of the assessment, I'll say. These are the things that your community cares about. It's the things that make up your community. We break these out into different themes and categories. These typically look a little bit different depending on the community. So these are the ones that we have used for Tallahassee. And you can see that we've got commercial and industrial property versus residential property. And then below that, we get to an even finer detail, looking at single and multi-residence properties, mobile homes, etc. And so that's really important when we continue through the steps to resilience. This information comes out within the attribute table and also within the tool. And so basically you would want to use this information when you're identifying options, something that you would, or some kind of project that you'd want to put in place for commercial and industrial properties might look a little bit different than residential properties or educational properties. So that's kind of where this granularity really comes into play. So I know this is a GIS group, and I'm sure you're all kind of wondering a little bit more about the data. So the major supporting data types that we use are the local GIS data. For assets, we pull in parcels and building footprints. And with that, we pull in the tax assessor class codes and different attributes such as effective year built. We can also use other data sources such as USDA SNAP retail locations, fire stations, different data sets that might be local to your community. And we can apply that to the parcel data so that it's all kind of in one place for our assessment. And then we also pull in, like I said, the latest threat data that we have available to us. For this assessment, we were using the FEMA flood hazard layers. We were able to actually pull in the latest FEMA data for Leon County, which I believe came out in February, so it was timed really nicely. The NOAA storm surge data, sometimes we're able to use local data models, you know, if those are available in a community. For wildfire, we were looking at the Silvis Lab Wildland Urban Interface data, and we also pull in some US Census metrics for that extreme heat assessment. Another data type that we use are major and minor roads. And this comes into play especially with flooding. A lot of communities are really interested in where roads may be cut off due to flooding. This is especially an issue along the coast. We just completed an assessment for New Hanover County, North Carolina, which is where Wilmington is. And if all of you are familiar, or any of you are familiar, that's where Hurricane Florence kind of devastated the area, and there were actually areas of the community that turned into little islands because they were so cut off due to the flooding. And so with this roads assessment, we use fire stations as a proxy for emergency services and can actually run an assessment to indicate if a road may be cut off to emergency services during flood events. So that's just another layer there. So diving into some vulnerability assessment concepts before we get into AccelAdapt here. This is kind of where the confusion can end up with just a brief overview like this. So I'll try to be clear, but I'm happy to answer questions about it. So vulnerability assessments begin with exposure. The key thing to remember here is that you can't be vulnerable if you're not exposed. So everything starts with the gray box there. And then this is where we start to pull in the attributes from that local data that I talked about with the parcels. So sensitivity often includes the type or the building use, and whether it's within a threat extent or not, kind of combines that exposure and sensitivity into potential impact. And so we have different degrees of impact then. For adaptive capacity, the easiest example of that is using the effective year built and understanding when the floodplain regulations were put into place or updated. This helps us understand whether or not a structure has higher or lower adaptive capacity or the ability to withstand a flood impact. And so then adaptive capacity and potential impact come together to tell us how vulnerable, again, degrees of vulnerability, how vulnerable an asset is to a particular threat. We do a similar flow chart with risk, and we can talk about that a little bit more if people are interested within AccelAdapt. We have some different graphics in there that will help make sense of that. So for assessing vulnerability and risk, using that flow chart and thinking about those degrees of impact or degrees of vulnerability, we apply what we call rule sets, and these are assessment criteria. These are two examples from Tallahassee, and because we just refreshed the assessment, that gave us time since our initial one to really think about how we were using the data and the criteria and make some changes so that we were able to basically apply the best available science to the assessment. So for flooding factors, for potential impact, we're looking at the criticality of that impact based on the building type and use, again, those building use codes. For adaptive capacity, we're looking at the effective year built and floodplain development requirements. And then for risk, we pull in the storm return periods that FEMA provides. So the probability based on potential flood frequency. And since you all are probably pretty GIS minded, you can think of these different criteria being ranked kind of 1, 2, 3. And we apply those in a matrix here, which you can see on the right. And those come together to multiply into values of high, medium, and low for vulnerability. And similarly with wildfire, you know, we try to stick to the same kind of vulnerability and risk models. but using different data because of the different type of threat. So here we're looking to see if the assets in the WUI area or the wildland urban interface area. Again, we're looking at that criticality of impact based on type and use. For wildfire, we actually looked at the drive time from the fire station and proximity to fire hydrant locations. And then we also pulled in for risk the Southern Group of State Foresters WUI Risk Index. So all of that information gets combined into these rule sets and kind of in these matrix-like multiplications. So just to drive home these concepts, this is a picture that we like to use a lot. Both of these homes likely have the same exposure. You know, they both may be within the same flood extent, but they have different vulnerability. So for example, the home on the left that's built up, it likely has higher adaptive capacity than the house that's at ground level there. And so that would result into different levels of vulnerability for each of these structures. So you're probably wondering, great, I have all of this information. How do I make sense of it? So within AccelAdapt and also within the spatial output data, we can pull out citywide analytics, so you can start to understand things at that larger scale. You can say like, okay, 7% of businesses are highly vulnerable to flooding, whereas 10% of our food infrastructure properties are vulnerable to flooding, and you can start to prioritize throughout the city in that way. We also look at the data at the census block group scale, or what we like to call the neighborhood scale, and this allows you to see different patterns of vulnerability and risk throughout the city based on asset and threat type. And then using AccelAdapt, we can start to drill down into the asset level, really looking at each of those parcels. And within AccelAdapt, you can start to understand the different rule sets and criteria that actually have gone into that parcel. So another really important thing that we like to bring in are socioeconomic metrics. And these are not really used within assessments themselves, aside from extreme heat. These are here to show us a co-occurrence of physical and social vulnerability. So you can start to prioritize different areas within the community in this type of way, where you might be looking at an area that has high vulnerability and risk, but also has low income populations. That might give you a hint as to what kind of project you might want to implement. We do like to use the most up-to-date survey that's available from the census. So currently, I believe for most places, it's still the 2019 5-year estimates. And then we also bring in sometimes the CDC's Social Vulnerability Index, and they have 4 themes that, that we can bring in as well. So all of this information goes into a tool that we have called AccelAdapt. And it's a comprehensive and interactive dashboard of the results, as well as a way to view the data that's been used and the different asset categories and threat data. A lot of the navigation features will look pretty familiar to folks if you're familiar with map viewers. But this is just a way that you can actually view and understand the results without having to fire up your desktop GIS. So with that, I am going to jump out into AccelAdapt. Janine, I don't know if we have any questions right now. I can take some.
Right now, I do not see any questions. Anyone who has any questions for Kim before we get into the demo, could you please put your questions into the question box identified in the chat? So we'll give folks a minute or two to see if any questions pop up. And if not, we will go into the demo.
Super.
And I'm giving you a coffee break, really.
Yes, much needed coffee break.
Awesome. So first question I have is, does age and health play a role in categorization for the tool?
Yes. So not necessarily. So the socioeconomic metrics that I mentioned, those really only get used as additional layers within the tool, except for extreme heat. And so that's the one that I mentioned was at the screening level. And so we can take a look at that one when we get into the tool, but essentially we use the census data to look at populations that are older than 65 and younger than 5, as well as median household income, recognizing that those population ages are those that are more likely to be affected by extreme heat events. And then we bring in the median household income as a way to represent adaptive capacity, suggesting that households that have a higher median household income have a greater ability to adapt to extreme heat events. I am not sure what happened on my screen share.
Well, right now I do not see any other questions. I do still see the tool. Oh,
Okay. Oh,
the screen share disappeared.
do you see it now?
Yes, I do see it.
Okay.
Not a problem. If there's no other questions, Kim, you can go ahead and go into the demo.
Okay, great. So AccelAdapt really is an online platform, but it also, I should mention, is our engine. So if you can imagine modeling all of this by hand would be incredibly time intensive. And so we've actually automated some of this, and AccelAdapt on the back end is our engine for a lot of this. AccelAdapt, the online platform, is what you're seeing here. And so each one of these looks fairly similar by community. As you can imagine, some of this is different. Each one is password protected, so it's not publicly available. When you go to your own AccelAdapt, this is what you see. It is a home page basically of asset threat pairs. And if you hit show all here, it gives you an overview at that citywide scale of every single assessment. And one thing I'll mention that might be best here is that when we talk about asset threat pairs, which you'll see a lot in the tool, we're talking about these different asset themes, which are across the top here, and threats, which are across the side. So commercial and industrial property and flooding, residential property and flooding, etc. And so that's kind of like one way that we delineate within the tool and look at the different types of assessments. Again, going back to the different asset categories, what you might do for transportation facilities and flooding could be different for residential properties and flooding. So it's on this overview page. As you scroll down, you can see each threat here, and there's a little bit of a description for each one. You can also jump into the map viewer for each one and view that. But then you also see every single high or medium combined vulnerability and risk value for every asset category for that threat. And each one of these is interactive as well. You can jump into the map viewer that way. As you keep scrolling, you keep seeing the different threats here: wildfire And since it just came up, we can jump into extreme heat. And hopefully with my screen share, it doesn't take that long. There we go. So extreme heat looks a little bit different. Like I mentioned, this is what we call a screening level assessment. And so we actually don't evaluate risk for this. We're only looking at asset vulnerability. So when you jump into the map viewer of the online tool, you start out at this city scale here, and then there's a lot of information along this bar over here, as well as the assessment criteria, which are those rule sets that I was talking about. And this is a little bit more manageable to view. You can see the high, medium, low here for each one. And so when we're looking at vulnerability, we're looking at the combination of potential impact and adaptive capacity. So for example, for potential impact, we're looking, the highest areas have the highest number of sensitive individuals, which are those age groups that I mentioned, and also have a high percentage of developed land cover. So as you can imagine, developed land cover would mean there's a greater urban heat island effect present. For adaptive capacity, areas that have high adaptive capacity, which remember is good, it's a good thing, has the highest amount of tree canopy and a high medium household income. So the other thing with AccelAdapt is that you can actually toggle these layers on and off. So you can begin to view the information that way. And also with extreme heat, and you can do this with the parcel data as well, which we can take a look at, you can click on an area and it will actually highlight which criteria went into that overall score. So you can begin to get a sense of what's driving that area. Within this map viewer, you can also view all of those socioeconomics information that I mentioned. Here we have a couple of different layers. We have population density, percent African American population, percent population with less than a high school diploma, etc. So you can click on one of those and it will show up as an entire, layer here, or you can toggle this overlay mode and just view the top percentile. And you can start to understand that co-occurrence of physical and social vulnerability then. So jumping back out, so we can look at some other assessments. I'll scroll back up to the top. Within each page, there's this overview and select asset threat button. And so this drop-down button is actually super helpful. It shows you all of the asset categories, all of the threats, and then all of the asset threat pair combinations. And because this list can get a little overwhelming, it's pretty light and you might not be able to see it through the screen share, but there's a little filter button here and you can filter all of the assets and then also all of the threats. So if you wanted to look at residential property and flooding, for example, you can click on that one. It'll take you back to the same screen here. There are some navigation features on the left over here. I won't spend a lot of time on those since I assume you all are GIS super users at this point. These are your zoom controls, and then we do have the ability to add extra layers here. So there are some that come standard, like the census block groups and buildings. These are turned off at this extent. But then with the City of Tallahassee, they wanted to include some of their data sets that are important for decision making. So these are ongoing, future, past projects, for gas projects, CIP projects, etc. So you can actually turn on your own layers along with the assessment results. You can change the base maps here, search for a location, or you can, I forget what the name for this is. You can stop the zooming, the zoom in and out. Boy. In the legend down here, you can see you can change from the percent and number, depending on what will make sense most for what you're looking at. Another thing to note is that because extreme heat is at the screening level, the other parcel level assessments are different. And so we can click on an area here and it will zoom right in. Hopefully my internet is okay with this. And you can see a new area popped up over here. So you can begin to get an understanding of high and medium combined vulnerability and risk for that particular area compared to the city as a whole. And you can actually start to see the parcels here. So you can also just navigate around the screen this way. And just like with an extreme heat, you can click on a parcel and go to your assessment criteria here, and it will highlight the different criteria that go into that particular parcel. Talking about the criticality of impact based on type and use, this particular property is a multi-residence property. So because it's in the inundation extent and it fits one of these different tags, it gets a higher potential impact than this single family property over here. So you can begin to explore the different assessment results and get an idea of different areas within the community that you would want to implement projects, areas that you might want to prioritize for different types of projects based on the asset type or the threat type. And I should also mention that all of this information that you see here within these assessment criteria are also in the assessment output. And so once you have your desktop GIS data, you can actually take this information and filter it, and so you can share information across departments. You can help provide an understanding for planning departments or for stormwater departments, and really use the assessment results in multiple different ways. So I want to make sure I leave enough time for questions.
Yes, and we have one question. How was the wildfire threat calculated?
Yes. So wildfire is actually a pretty interesting one. I don't know if it's because I live in the West or if it's just because it's a different assessment. But for wildfire here, let's see if I can actually bring up the assessment criteria. If I click the right thing. So for wildfire, we use the Silvus Lab WUI risk, or sorry, the WUI exposure extent. And so that's the wildland urban interface, which I suppose not everybody is probably familiar with. The wildland urban interface is where structures are within that wildland area or very close to it. And so Silvus Labs has a data set that's based on structures and land cover. That's the WUI area. And so that's what we use for exposure. So if you remember, you can't be vulnerable if you're not exposed. So we use that as the layer to understand where structures are spatially within that extent. And then for potential impact, it's very similar to flooding, where we're looking at the type of building. We're looking at if it's within the exposure extent and if it's a high criticality. And then for adaptive capacity, that's where it gets to be a little bit different than the flooding assessments. That is when we look at the fire hydrant locations and the drive time to a fire station. So this is something that's been calculated with those Rhodes assessments. We use point locations, I believe, for the fire hydrants, and we look at the proximity to fire hydrants. And then for the risk factors, the Southern Group of State Foresters actually has a risk layer. And so that's an entire index that they have created that we've pulled in directly. So for risk, we would typically be looking at probability and consequence, but since they've already combined it here, we've just used their index directly. I hope that answers the question.
I think you hit all the high points there. And I have another question. Has your company considered including other threat assessment categories, such as water scarcity or food insecurity?
Interesting. For, let's see, for food insecurity, that is something that we would like to be including a little bit more, especially as it relates to emergency response, power outages in low-income populations. We recognize that that's a pretty big and combined issue with flooding or other extreme events. The threats that we are typically trying to model here, A, have spatial data available, and B, are typically considered to be climate-related threats. But that's not to say that we wouldn't try to combine that with flooding, for example, or storm surge as a way to determine different types of vulnerabilities. Janine, will you remind me what the other one was?
Sorry, I was clicking through to make sure I wasn't missing anyone.
Okay.
So in terms of threat assessment categories, is that where we're heading on?
Yeah, with food insecurity and
water scarcity. So for our assessments right now, yes, we did storm surge, flooding, extreme heat, and wildfire. And those are the 4 assessments that we had done. And we've talked about exploring other assessments like wind damage and such. So
right. Yeah, for water scarcity, that's another one that's a little bit more difficult to model. I think what it would come down to is if that data is available at a scale that's useful. We haven't necessarily done it in the past, but that doesn't mean we couldn't do it in the future. It would definitely take some R&D on our part, but it is a growing concern. Maybe not as much for the Southeast, but definitely is something that we're very aware of in the West here. So it is not out of the question, I would say.
yeah, and I will tack on as you're touching upon too is one of the caveats with all of these assessments is the availability of the data and how current it is, how often it's updated. And so tacking back on, like, for example, food insecurity, as you're saying, it's a growing threat that people are being more cognizant of, especially with the pandemic. And so it's not only just knowing the locations of what we would call fresh food sources, but having to survey what is that supermarket actually a fresh food source? Is it not? Having ideas of the neighborhoods. There's so much transportation disadvantage. And some of those metrics we have included in this tool here, but not to the degree for those certain threats.
Yeah, that's right.
And again, I apologize for multitasking here. And I hope to Raymond that answered your question. We have at least 5 minutes left in our session. Does anyone else have any questions or comments they would like to share with the group?
I will say that as we're waiting for any questions that come in, it is definitely worth noting that we are thinking about additional threats. And we're also thinking about different planning horizons as well. So we're looking at future scenarios, often, obviously often with sea level rise. But different threats that we're looking at do include high winds, as well as, we've also looked at algal blooms and tidal flooding. One that we haven't had good data access to is compound flooding, which I know is a larger issue in Florida. So hopefully data for that becomes more available as time goes on.
Yes, and I know you all are already working with some communities regarding wind damage is something that we're also considering as well. And again, that goes back to the issue of availability of the data. But I do have some comments coming in saying great presentation and thank you for sharing all this information with us, Kim. And really thank you for presenting today. It was great. Thank you so much.
Yeah, well, thanks for having me. This was great. I hope you guys have some really nice sessions throughout the day.
Well, for everyone else, again, thank you again for sharing all this information with us, Kim. Again, another great thank you. You're getting accolades over here. So awesome, awesome. So we'll be at the end of our session now. We'll be taking a break before the next set of sessions starting at 10 o'clock today. So thank you all for joining us and have a wonderful day and enjoy the workshop.
Thanks, everyone.